Welcome back for another episode of the 5G Guys. I'm Wayne Smith and joined by my co-host, Dan McBall.
Hey, Wayne. Hey, everyone. Great to have you back. Thanks for joining us again. This is part two of our series called The Life Cycle of a Cell Site. If you missed part one, we covered the design phase of how cellular networks are implemented. Go back and check that out. Or not, you can always do it out of order. But today, we're going to tackle the construction phase of actually getting these cell sites and networks built. So, Wayne, you and I are both pretty well versed in the whole process of these cell site construction projects, but I think you have a little bit more, if not a lot bit more, background in the construction side than I do. So, last time you kind of played the role of interviewer, and let's swap today. Maybe I'll kind of ask you about the construction process. You can tell us, how you see it rolling, and we'll go that way. How's that sound?
This sounds great. Yeah, at Vertex Innovations, our show sponsor, one of our main roles is construction management, and we manage hundreds of vendors across the country in every state building these sites. And so I do have some, current information, my background too. I am a tradesperson. I bypassed college, went into the trades and went to college later in life, so I do construction holds near and dear to my heart. I love working with my hands and I love seeing something come from nothing to
Hmm.
something as magnificent as a cell site and what it does for society. So let's jump in.
Awesome. Great. Well, maybe let's start off at the top. Kind of give us a sense for what does construction mean? What are the types of trades, the type of construction work that it really takes to make a cell site happen?
Yeah. And so as we spoke in the last episode, there's a various type of sites, right? And one of the things I think that would be easy to explain would be a raw land site or a tower site, if you will, which make up about, 30 to 40% of all cell sites. Rooftops are another variation, but we'll talk about cell sites because it does, the tower sites, because it does highlight all the different trades involved and what it takes to get something done. So once the site location is selected, in a raw land site, one of the first pieces to that site is the civil work, and what is civil work? Civil contractors come in and build the road. It's that simple. A lot of these land sites don't even have road access. And so they are building access into the property of wherever the cell site location is. And so the first people on board a lot of times are the civil crews. They're prepping the site, doing the land work. They're excavating to make sure that, they have a good grade and they can set the pad area for the site. And, being if it's a tower, a lot of times there's caissons involved or, it has to be drilled, tested in order to support the tower structure. Also, there's in the civil side of it is the concrete crews. We need concrete there in order to have equipment pads, in some cases, foundation for shelters. There's a lot of different, variations of what a macro tower site would be. Some of them have shelters, like it's a maybe what is that 10 by 20 building that's pretty secure against the elements. And then in some cases, we just use pads that set an outdoor BTS equipment on or cabinets. And, both are used pretty commonly. It depends on the architect and where you're at and what you're having there. But the civil crew's job is not only to drill that caisson, and that's another construction crew. Normally there's specialty contractors that come in and all they do is drill those caisson holes to set the tower. You have your concrete crews that, finish the concrete. The caisson crew would also set the anchor bolts. Anchor bolts are really critical and for the tower structure. And you might know this better than me, but normally on a monopole, the caisson goes down. Is it a third of the length of the tower? It's pretty deep, huh?
Well, it just depends. I mean, I've seen, my first job out of college, I was working in the southeast part of the US, and we would go to set the foundation for a 200-foot monopole at sea level, and you couldn't go that deep. You hit water at 4 feet, right? So
Oh
that's
wow, yeah, that's
so
cool.
and then, you go somewhere else like the Rocky Mountains and, you got granite. You ain't going, 100
Too
feet
deep,
deep
huh?
with granite. So it all is, it depends, and that's where your architectural structural engineers come in, and they work so close with the construction folks to deal with those anomalies and figure out unique ways to put the right kind of foundation. So yeah, but yeah, you're right. If you're in the middle of Kansas, you can go. It can be a pretty deep foundation, I think.
Yeah, and so once the concrete's there, we also have, the industry requires concrete break tests. So we have a testing company involved, and their role is to come in and make sure that concrete meets the engineering specifications based on the structural analysis. I mean, if it's a high wind zone, that concrete may have higher tensile strength. So we have another specialty contractor involved just in the civil side of it. A lot of times when they're prepping the site, a part that we haven't talked about much, but for towers, they have a lot of grounding. And so the site has to be grounding for lightning protection. And a lot of times during that civil side of it, they'll trench and build and set the lightning rods and lightning protection all around the site. I think they're still doing it today, but any of those, that site external pieces, the fencing, the monopole, the shelter, all of that has to be grounded. And then that grounding has to be inspected and tested to make sure that it's the right ohms so that if a lightning strike did hit, it wouldn't destroy all the equipment. They're trying to direct it away from the site. So civil's a pretty detailed piece of it. And then we assume that the civil's done and that the building or cabinets are ready to set, which brings us to the tower. Now you probably have a little bit more insight on how towers are done. I did mine in early careers. I think I built about, I don't know, 50, 70 tower sites myself, went back when I was a foreman working for a GC. But once you talked a little bit about the tower side of it and how it stood and that piece of it.
Yeah, sure. So there's really, at the end of the day, three basic types of towers. There's self-support towers, which a lot of people probably envision when they think of a tower in their mind's eye of, it's a lattice kind of tapering shaped tower that has sections that are stacked on top of each other, right? And so they might be like 20-foot sections. They set the base section, and then they have to have a crane or a man lift of some sort that then sets the second section while they've got climbers up there bolting those sections together, and then just keeps stacking the tower till they get to the top, right? You talked about monopoles. Monopoles typically are going to be like a light pole, but just much thicker, much more stout. Same thing, they get stacked in sections as well, where they've got sleeves or whatever that they get connected together as it gets taller, but it's a pole, right? And any coax or cabling or anything's going up through the center of it versus a self support, you would see that cabling and stuff exposed to the elements. And then the third type is a guy tower. So a guy tower, you see those a lot more in really tall towers that can get upwards of 1,000 feet. You see them a lot more in rural parts of the US because they're just a straight, non-tapered version of like a self-support typically, but they've got guy wires that are anchoring them at different points. And so that requires a lot more land because you have to have all those anchor points that can be hundreds of feet out from the tower. And you can have 4, 8, 12, 16 guy wires depending how tall that tower is, and it's a whole different process because you're tensioning. So those are the three basic types, and the way that those get built is again like cranes, tower climbers on the pole, and we can get into it a little bit later, but there's unique processes like gin poles where you have basically a temporary tower that's attached to the first section of the tower that extends its height so that you can use that to help you set the second section. And then you just keep moving that up the tower until the tower's done and then you take it back down. It's sort of like scaffolding, but it's attached to the new tower you're building itself, right? So I mean that's the basics. And then you got all these different unique structures, right? You have water tanks and you've got that's all they're just all unique how you handle those. So hey, real quick, a quick word of thanks to today's sponsor, Vertex Innovations. For over 17 years, Vertex has been building the nation's wireless and broadband networks. Providing project management, network engineering, and construction oversight are just some of the ways Vertex helps their clients. So if you're looking for more of a partner to help you with your wireless network designs, construction, implementation, or operations, reach out to Vertex. You can find them at vertex-us.com. That's VERTEX-us.com.
I think what we're getting to here in the process is it depends. There's a lot of people involved and a lot of cross coordination amongst many different trades to, accomplish one outcome. I talked a little bit about, pre-manufactured shelter. In some cases, that has to be built. You wouldn't use a shelter, it's not cost effective, or there's just a bunch of different reasons. So you have to have, a carpenter crew come in and construct the shelter side. So, what's crazy, there's just a lot of different elements depending on the specific situation.
Mhm.
Raw land sites are, pretty easy. I think generally a 2 to 3 month time frame for one of those sites. There's not a lot to deal with there. Buildings could be 6 months,
Mhm.
time they get through zoning, working with the municipalities and getting there. But other key elements to focus on is power. Every cell site needs power. And to one of your analogies earlier in our podcast, one of the previous is that everything's connected in the wireless world, and
Mhm.
power is one of those important components. Now, I think, there's always that outlier, like way in the mountains, they may have a solar application with generation, with generate, but they still need power and a lot of power, right?
Mhm.
Average cell site, what is that? 200 to 600 amps of power in order to push that gear and take the site. So power, is what it is. Some rural locations that can be extremely difficult.
Mhm.
Even in some metropolitan areas, getting power is a long pole in the tent. You're working with, the utility, whoever it is in that market. Maybe they don't have transformer space. I think everybody in the country's heard of the grid problems the U.S. is having. The electrical power grid in the United States is kind of antiquated and it needs to have capital investment in order to rebuild out the utility power grid. And, with cell sites today, what's interesting about it, we're talking about a land site, which is out there. But if we talk about small cells and other, that's a lot of power in a lot of locations really quickly.
Mhm.
And so power is one of those, and it's usually done, it can be done by, a specialty contractor. It might be done by the general contractor who has the site, but a lot of that is trenching. And, what's involved in putting in power, usually encased concrete from the right of way of where the power location is into the cell site location. So it's not super easy. They lay conduit in there and a lot of times they mark it and they may pour concrete on top of it to make sure it's encased where it can't get cut.
Mhm.
So that they have good redundancy there. But power is a critical aspect of the construction process. And then in the coordination of it, you're now coordinating with the utility, which are not notoriously fast in getting anything done, right?
Right.
And you have to coordinate that with the delivery of the site. So power is another important one that requires a lot of different trades involved.
Mhm. Sometimes do you sometimes see power brought in, like, through aerial feeds, like power poles, utility poles?
Yeah, well, a lot of and a lot of the new small cell technology is powered, in that way, and more cost effective instead of having transformer locations down. And so that a lot of the small cells, if you notice in some large cities, you look up, you might see a small cell hanging on an aerial between two spans.
Mhm.
A lot easier to deploy. You're really not taking up real estate per se, like on the tower itself or on a light pole. And so there's a lot of new applications that are coming out that does, between spans being powered by the utility pole that it comes in on.
'Kay. Got it.
Yeah.
What else? So power there, and I think you're referring to that. I think that episode we called it "Wireless Needs Wires," right?
Yeah.
You gotta have
Yeah.
so there's more than power that's a wired service we need as well. We've talked about that, right?
Oh, yeah. Next one up is fiber. And, why is fiber critical? Well, it's the internet. It's the interconnectivity to the whole world at light speeds.
Mhm.
Wireless is fast, but not near the speed of data transmission as fiber. And so fiber is critical in today's modern networks, even though years ago, when you and I started, a lot of it was copper based plant.
Mhm.
Nowadays is all fiber. And fiber is one of those technologies that has its own set of specialty contractors or OSP contractors, if you will.
Mhm.
It's pretty easy if there's a fiber ring close to the location of where the site is. Then you can go there right away, pick yourself a meet me point and bring the fiber from there into the private land. Fiber is also the way it's done. A lot of times it's also prepped to the site as power is. And so you may see in a single trenching ditch, or they may use a hydro bore. They do a lot of boring these days. And for you folks that don't know what hydro boring is, it's like a drill that drills under the earth and they pull through a plastic conduit and without disturbing the surface of the earth. It's pretty popular in a lot of areas because it reduces restoration costs on cell sites. But that power and that fiber or telco, as we called it, two critical components. A lot of times fiber delivery depends on where it is. It might have a 6-month delivery or longer,
Mm.
delivery to that site. So if you're a carrier trying to build a site, you have a contractor involved, you're trying to coordinate that where power and fiber come together with construction in a reasonable time frame.
Mhm.
That makes sense?
Yep. Yeah, it's a shell game for sure, trying to coordinate all these different trades and delivery of construction phases all to kinda coordinate and happen at the same time. It's kind of a big puzzle, huh?
Yeah. And so we've kind of covered the elements, the shelter, the civil,
Well
the
well, now
power.
so now we've got a tower in the air. We've
Yeah,
got
that's the next
we've
phase,
got a
right?
foundation, we've got a shelter, we've got power, we got fiber, but so are we done?
Nope. Got the most important part. It's the interconnectivity of the line and antennas on the tower. And in today's world, I think for sure, and it exists, there's a couple different types of antennas. One, we have to have a GPS antenna, right?
Mhm,
For timing. And then you have your antennas for the different technologies and bandwidth. But that is another critical piece of it. Now, a lot of that's moving to fiber. Some of the equipment's moving out of the shelter and onto the tower, like remote radio heads and different things like such. But the specialty crews, so, in a typical general contractor, you might, for a smaller mom and pop, you might have one crew that does both civil and the tower work. And a lot of now more modern construction companies, they have a civil crew that comes in that then lays the foundation for the next crew, which is the tower crew. And that tower crew comes in and their role is to run that technology. If it's in a monopole, maybe in the center of the pole
mhm,
or on the outside of the pole. And they have to, and as they build that, it has to be done to engineering specifications,
mhm,
whatever that carrier may be to certain decibels. And so it takes specialty contractors and tools. So let's talk about that for a minute. There's a lot of climbers out in the world, but nowadays that's a man lift. So how do you build a tower? How do you do it? You need a crane and a man lift in order to successfully and safely build that site.
mhm,
So we're starting to build a lot of construction, large, heavy industrial construction equipment involved. We're getting tons of different suppliers of it all. Very few companies have all those trades in house. And so it's a coordinated effort by that construction company to get the whole thing built. And the final piece is the line antenna. You want to add anything to that? Because
Well,
I don't want to, I
I
don't want
think
to
the
add.
one thing I'll add is when I talk to, people that find out what I do for a living and there's a common misconception I've heard from people that they think the tower is the cell site. And so I kind of take for granted the fact that there's really only one wireless technology that I know of in the world where the tower is the radio frequency transmitter, and that's AM radio. In AM radio, you have a bunch of towers that are the antennas, but everything else that we do in this world wirelessly, the tower is just a structure to get our antennas up in the air. And so the antennas are attached to the tower, and so a lot of people, they don't even necessarily realize that. And so, yeah, it takes these line and antenna guys. They're the ones that are running the fiber or the coax up the tower. They're the one attaching those antennas. And when you're looking at a tower from the ground and you see those antennas up there, they don't seem like they're that big, but these antennas can be 8 feet long, 12 feet long. They can weigh, hundreds of pounds. So it's not like these tower guys are climbing up and down the tower with these things on their backs, right? They have to set up rigging where they've literally got like a wire relay that's, got a winch on it that's basically pulling all of this heavy equipment up to the height they need to install it, with the tower crews up there in a man lift or climbing to then fasten it, attach it, so on and so forth. So I guess that's what I would add, is just, helping people realize that the cell site itself is the antennas and the lines attached to these structures.
Yeah, very good point. Very good
Yeah.
point.
So we kind of have a basic overview of all these steps. In your experience, what are the long poles in the tent? Like, what typically is the most likely trade or step we just reviewed that can cause the construction project to take the longest? What's the most difficult
Well,
part of it?
so, and this is pay homage to my group for sure. I think project management, this is where skilled project management, we don't talk about that as a trade in a sense, but it's one of the critical hubs to make these sites work, because what they're doing in the background is coordinating the power, for instance, and that is a long pole in the tent. You know, does it exist? If it's there, how long is it going to take to deliver that? Along with power is the backhaul capability, or fiber. In a lot of instances, fiber is a super long pole in the tent. It could be, 6 to 9 months on delivery, and that may not work. So they may have to come up with another technology like microwave in order to get the site on air, because sites are built to utilize a license that was purchased by the carrier, if you
Mhm.
would, right? And that is a key indicator in the project management overall schedule of building, to get that site on air, to bring that license and utilize that license that was purchased.
Mhm.
I don't know, we could, it's a whole nother subject, but those licenses have a time state that there's a date on them when they have to be utilized. And so project management is the key piece to bringing all these things together. One of the, I think, critical milestones in any project is, a lot of people may have different words for it, but we use the word room ready. What does that mean? It means that the site is ready, it has power, the inside of the site is built enough to have rack space and power distribution. That way, that when the fiber is delivered, it can be turned up and turned on. And, that room ready date is now the whole site may not be built at that point, but what that means in room ready is that we're ready to accept the fiber, test the fiber, and do that interconnectivity to the site. And it can stand on its own. Now, we still might have to build the fence, put the finishing touches on the tower, all kinds of other like tasks that are involved. But the room ready is the accumulation of those long poles in the tent.
Mhm.
Because you could build a great site and not have fiber, and it might sit there for 4 months,
Mhm.
right? Or you could build a great site and it has fiber but no power, and it'll sit there for 4 or 5 months. And that, it's not a very effective use of capital. So those are, I think, the two long poles of the tent until the pandemic, which then brought supply chain type issues. And it could be, you're missing an antenna, you're missing a
Mhm.
GPS, whatever the device is
Materials,
there,
right? Coordination of all those
materials,
pieces and parts that are, fasteners, you name it, right?
thousands of parts. So those are a couple of the ones that stick out for me in the critical milestone of that room ready date.
Mhm.
And it signals that, hey, we're getting close, but we're not finished.
Got it. So you've touched on a lot of these steps, civil. We haven't talked a lot about rooftops, but it's a similar process. It's just your trades are guys that have to be able to work up on the roof versus climb a tower, And
Mhm.
I've seen rooftop sites in the middle of urban corridors where you got to shut down the street on a Sunday morning and bring in a crane or even a helicopter to drop the equipment up on the rooftop, because you can't shut down the street to get that crane to lift that heavy, because you're not taking that equipment up the stairwell of the building, right? so
Yeah.
so it's a similar process, but more specialty, right? And so let's talk a little bit about specialty skills. What are some of the highlights of specialty skills that some of these trades have to have? They're, we talked about concrete guys, but what other specialty skills, do we see out there?
Ooh, man, that's a big one, but it also touches on a really big subject of the labor shortage in the wireless
Hmm.
industry. I mean, right? So climbers, you know, that's really tough to have enough skilled, trained, safety training. Let's say that climbers who can work on the site.
Hmm.
You know, I think that's one of the definitely where we have a shortage are trained climbing personnel.
Hmm.
And there's a lot of great safety, companies out there that teach them. So when you think about climbers, it's you have to be fit.
Hmm.
It's not an easy job going up a 120-foot tower straight up. You have to be focused. And so there's a lot of vendors just to support the climbing industry itself.
Hmm.
And then riggers, we mentioned cranes. Cranes are an integral part of building most sites, whether it's a rooftop or a monopole. You're having crane operators out there setting that. And, there's riggers,
Hmm.
you know, let's think equipment operators, right? Like those skills and trades like a man lift. I think a man lift pretty much mandatory on every site these days, isn't it?
It's pretty
Yeah.
common. Yeah.
Yeah. I mean, it reduces the amount of manual climbing. It's quicker up and down just in case you do things, but learning how to operate that equipment and be satisfied, and be safe on it. We talked a little bit about excavation, heavy equipment operators, which are always in a short supply.
Hmm.
I mean, there's trenchers, there's loaders, there's backhoes, there's dozers. Also, along with that, there's asphalt delivery or gravel dump truck drivers and delivery on it. I mean,
Hmm.
we're talking that almost every type of construction trade is used here. A lot of the sites require welding, so you got to have specialized welders that come out. Also, metal fabrication is a critical piece. We're building sites outside, so it has to be galvanized and has to withstand weather over a certain amount of time. So you have welders and machine fabrication involved. The coax installation, it's a trade and it requires training itself
Hmm.
in order to install. Also, the fiber, fiber's great, but a lot of times it's not pre-made. And so you need to have fiber splicers in order
Hmm.
to terminate that fiber at the correct decibel and power reading so it can be tested and it meets the network availability. Other specialty skills. I mentioned project construction managers. So the difference between project manager versus construction manager a lot of times, and I talk about it, it's one of the big things at our company is that project managers, they're getting the tiger by the tail on all of the trade. The construction manager is really specific experience working with and coordinating all those trades in the field so that it's built to the engineered drawing specifications.
Hmm.
A construction manager needs to make sure the grounding is done appropriately, needs to make sure that the anchor bolts are tight, to a certain torque
Hmm.
specificity for the wind. Because, towers do fall in different events. And so you have those two specialty skills, which are in short supply,
Right.
as you can imagine.
Right.
What did I miss, Dan?
I think you kind of hit a lot of the big ones, and you talked about like those coax and fiber installers. These aren't just construction folks. That test equipment is complicated, high dollar. So these guys are sort of where construction and engineering kind of meet, right? They have to have those labor skills to do the physical part of the job, and they have to have those, skills in terms of understanding the technology and how to test it and when it's right, when it's wrong. So that I think that's a unique one. And then I think you talked about it. A lot of these trades exist in other industries, but the unique thing about tower climbers is they're doing the same things that other people do on the ground, but they're doing it at heights in the elements. I would say in my old company, the biggest reason we had new construction folks wash out, they knew all the skills, they knew how to weld, they knew how to do all these things, but you get them up at 100 feet and they couldn't let go of the tower. Well, guess what? If you can't have your hands free and trust your gear to protect you and use your hands, you can't work. And that was probably the biggest reason we had guys wash out that were new to the industry, was just applying their skills at heights in the elements. So I would say that's probably the most unique skill.
Well, let's give a shout out to Nate. Talk
Mhm.
a little bit about Nate because it's an integral part in our industry and they deserve some credit for what they've been able to accomplish.
Well, for sure. So, this talks to the safety element, right?
Yeah.
And how safe is it, or how dangerous is it to do this type of work? And it can be very dangerous if not done right, and if there's not a focus to detail and attention to doing things safely and making sure the folks doing the work have the right supplies, the right materials, and most importantly, the right training. And that training is not a one-time thing; it's a recurring thing. And so, Nate is one of several organizations kind of in the industry that has a focus towards safety. So used the acronym N.A.T.E used to stand for North American Tower Erectors, and it's an industry trade organization that was born out of the folks that build towers for a living, and they really take a proactive role in terms of setting certification standards, testing standards, practices. They send alerts out when there's recalls on safety equipment that is failing. You name it, they play a very active role. They work with the federal government, and they work with a lot of the federal agencies that also have a responsibility to keep workers safe. And so they definitely play a huge role in the wireless industry. A lot of the construction workers that are doing this work, they have to go through a certification process where they hold a certification that's governed by the North NWSA, a subset of N.A.T E, that basically says, yeah, this person is qualified and has been tested to know how to do this work safely. And then there's other organizations, then, OSHA, Occupational Safety and Health Administration, ANSI, ANSI, American National Standards Institute, TIA. There's all of these other organizations that set standards that say this is how you should work safely. These workers have to understand those standards. They have to comply with them, and they have to learn how to do things like how to rescue another tower climber. I remember a case where there was a tower climber working. He hit a beehive, got stung by a bee, went into anaphylactic shock on the tower. And another climber had to climb up to him and rescue him and bring him down the tower to save his life. You have to be taught how to rescue yourself off of a tower when something goes wrong. I mean, and we've talked about, radio frequency health in other episodes, how to operate safely around transmitting devices and antennas so that you're not putting yourself at risk. So shout out to the workers that do this work, and shout out to the organizations that keep them safe. Huge part of this aspect of the business.
Yeah, you just triggered, for me, we're just talking about, building a site right now, like new construction. I think one of the pieces of our industry is, dude, there is a lot of ongoing modifications and maintenance to these sites. And so when we talk, there's and I misquoted in the last episode. I think I went back and checked my numbers. There's almost 500,000 cell towers and cell sites in the country today. I think I quoted somewhere around 300 grand, but, you know, 500,000 sites that have to have maintenance. Those network elements, what's interesting about wireless technology is things that we did just 5 years ago no longer exist. New antennas, new utilization, the way the coax is done. So when we talk about trades, we're talking about new construction and all the various components. I did think I see at one of the times in the project management life cycle of a tower, new roll-in site was about 700 to 1,000 tasks that had to get done. And those are milestones along the design construction process. And so when we talk about construction doesn't stop with a new site build. It continues on and on and on and on. And it takes a lot of trades to do it. One of the things I do, want to highlight that's close and near dear to my heart that paved a great way for a future for me and my family is working in the trades. I'm going to read one of Mike Rowe. He is an advocate for the trades and learning what the trades are. And you and I just highlighted like 25 or 30. maybe more specialty trades. And I think I admire Micro for what he's trying to do and bringing the trades in. It gives a sense of accomplishment. But here's one of his quotes. In a very general way, our society has fallen out of love with the skilled trades. Part of the problem is myriad of myths and misconceptions that surround the jobs themselves. But the biggest cause is their stubborn belief that a 4-year degree is the best path for most people. Micro. And why do I bring it up? These jobs that we're talking about and these trades, it takes years of experience to get really good at these skills. And, it's a little bit of aspect of every type of trade you can think of to build wireless or telecommunications technology sites. And it is a critical skill. If you take a step back and 10,000 plain view, these trades are building a way for you and me to communicate with our loved ones and society to interconnect in ways never thought of before. So yeah, I have a passion for the trades, and now I mean to get on my soapbox, but it's a great career, and it allows you to learn so many different things.
Yeah, for
And
sure.
that's my basis, right? I learned all these different trades, and it stood the test of time in business.
Yeah, for sure. Yeah, I mean, there's so much buzz about things like AI right now, right? And it'll be a lot longer down the road before we see the physical labor required to build something like a cell site replaced by technology. It still requires human hands to make these things
Yeah.
happen, and it will for a long time, if not forever. So, well, this is, I think you're touching on, we may do another version, another episode in this series about what happens once the site's built, and that'll probably be the next one. We'll talk about now what happens after it's built in terms of ongoing maintenance and modifications to the network. So, I think this is a
Like operations and system performance and their roles in it, because
yeah.
they have two big roles in it.
Yeah. So tune in next week for the third part of the series and the life cycle of a cell site. Great overview, Wayne. Thanks for tapping into your expertise on the construction side. And it's a big part of the other process for sure.
Yeah, thank you, Dan. I love talking about it. It's a passion of mine. And if any listeners out there, man, we love you, tradespeople, and the people who do the. It's a collective group, man. We're making something happen for everyone.
Well, just like us, if it wasn't for you, the construction guy, and me, the RF engineer coming together, the podcast wouldn't be the same. So thanks for joining us, everyone. As always, check us out at 5gguys.com. Until next episode, thanks.
Thanks.
Thanks for listening to the 5G Guys. For more resources and to connect with Dan and Wayne, check out their website.